Plywood is a versatile material manufactured by gluing together thin layers of wood veneer. Optimizing the production and value adding is essential to modern plywood production. Extra value is created by making the most out of the raw material in both a profitable and a sustainable manner. This video shows the whole plywood manufacturing process, from logs to veneer all the way to finished plywood panels. The veneer production process starts in the log yard. Logs are sorted into different classes by their length and diameter. Sorting optimizes the soaking, debarking, and cutting stages and minimizes raw material waste. Any waste is usually used for energy or pulp production. Veneer peeling includes block centering, peeling, veneer analyzing, clipping, stacking, and stack handling processes. Each of these steps affects the final production yield, and therefore determines the entire veneer manufacturing chain's profitability and the quantity of produced face quality veneer sheets. Optimizing veneer clipping and peeling maximizes veneer quality and increases the entire plant's veneer production capacity. As wood raw material represents the highest percentage of production costs, discarding even small veneer scraps is costly, and these should be recovered to eliminate waste. Recovery is possible through proper composing that includes intelligent defect detection and clipping. These full sheets are used as plywood core veneers, and since a single full sheet takes up less space in the veneer dryer than multiple smaller veneer strips, composing also increases drying efficiency. Veneer drying is crucial in veneer production. The drying process uses hot and humid air to remove water from the sheets until they reach optimal moisture for plywood production. Proper drying efficiently improves veneer quality and increases production yields. Optimal veneer drying conditions, equipment, analyzers, and processes produce more high-quality veneer with less energy, raw material, and waste. Modern veneer grading solutions include analyzers, such as visual, moisture, or strength analyzers, to grade each veneer sheet and determine its structural properties before it is used in plywood production. Analyzers determine if sheets should be patched, composed, or scarf jointed before use in plywood manufacturing. Patching holes and knots of the veneer is one of the most cost-effective ways to improve the end product value by creating more valuable plywood grades. Patching increases the amount of usable veneers for plywood. In face veneer composing, strips as small as 200 mm can be composed into full-size veneer sheets. This is especially important when manufacturing birch and other hardwood plywood, as it is important to make the most from every inch of the raw material. Butt joints ensure the composed veneer sheet's quality while remaining invisible. In core veneer composing, random strips of veneer can be composed into full-size veneer sheets used inside the plywood panel. This is especially important when manufacturing birch and other hardwood plywood, as it is important to make the most from every inch of the raw material. Butt joints ensure the composed veneer sheet's quality while remaining invisible. Core veneer composing is one of the best ways to utilize all raw material instead of chipping them to pulp or energy. In scarf jointing, precut sheets are glued together and then cut to the desired panel length. Scarf jointing can be used to produce practically any length of strong, long-grain veneer sheets. The veneer to plywood process starts with lay-up. Face veneer, long core veneer, and cross core veneer sheets are automatically fed onto the layup table in the correct order for cross-ply construction. The even layer of glue between each layer creates the strongest bond. Optimized glue usage with one-sided gluing is one of the ways plywood can be manufactured sustainably. Hot pressing brings each plywood panel to its final mechanical strength. Plywood panels are first pre-pressed at room temperature to make them strong enough for automatic handling. Then, the panels are compressed between hot press platens to finish curing the glue between each veneer sheet. Some defects cannot be repaired before layup and pressing, so panel repairing is necessary to fix any defects remaining in the finished panels. Repairing these final defects significantly improves the final panel quality, increasing each panel's value and thus increasing revenue for the whole mill. This product line manually repairs the birch plywood panels, but there is also repairing line solutions that automatically completes the entire process. Different end customers have different requirements for finished panels, and therefore, the final process looks different in every mill. Customers often require trimming, sanding, edge painting, overlaying, packaging, or other processes before shipping, and each mill customizes its final process to meet these requirements. Modern mills often incorporate automated intralogistics solutions during the finalization process to ensure safe and efficient production flow. Plywood has shaped the world since it was first envisioned over a century ago, and it's still one of the most common and versatile materials that's used in construction, furniture, car, and many other industries. Modern plywood production efficiently and sustainably uses all the raw material, and any waste is usually used for energy or pulp production. This way, plywood producers all around the world can make the most value from their raw material.